Alright guys, I wanted to give you some solutions for your acceleration problem set. Here, number 1 says a race car accelerates at a rate of 15.6 meters per second squared. That is my acceleration. So I'm going to write A equals 15.6 meters per second squared, or meters per second per second. That's how I look at it. If it starts from rest, that tells me that my initial velocity is 0. So VI equals 0 meters per second. Now we always need to make sure that we are in the metric system, metric units. So if it starts from rest, how much time until it's traveling at 325 kilometers per hour? So my final velocity is going to be 325 kilometers per hour, and I'm looking for time. Now this is nice because I have everything but time, and so I'm going to be able to use this equation, VF minus VI over T. Now, I do see one problem here. Let me see if I can get this to focus here. Okay, I do see one problem, and that problem is here I'm dealing with meters per second and meters per second, but here I have kilometers per hour. So the first thing I do before I plug in any numbers, I need to make sure all of my units are in meters per second. So I'm going to convert this here, 325 kilometers per hour. First thing, I have to get the kilometers to meters. So kilo means 1,000. So there are 1,000 meters in 1 kilometer. This is going to allow me to eliminate kilometers. Now I need to get rid of the hours. And well, 1 hour, I'm trying to go to seconds, has 3,600 seconds in it. Now if you didn't know that, you could say 1 hour is 60 minutes, and then 1 minute is 60 seconds. But either way, 60 times 60 is 3,600. Now this hour up top cancels with this hour in the denominator, and we can just multiply. So I'm going to do in my calculator here, 325 times 1,000 divided by 3,600. And I get a final velocity of 90.3, or I'm just going to leave it at 90 meters per second. So now let's plug stuff in. A is 15.6 equals VF, 90, minus VI, 0, over T. Now here's where the algebra comes into play. I need to get this T, first of all, in the numerator, and I need to get it by itself. So I'm going to multiply both sides by T. That time is going to cancel with that one. And now I'm left with T times 1.56 equals 90. If I divide both sides by 1.56, I will get my answer. T equals 90 divided by 1.56, 58 seconds, approximately. Okay, let's look at number 2. 2 says a truck falls off a cliff. If the cliff is 33.5 meters high, I'm going to go ahead and draw my cliff here. So we are falling this distance of 33.5 meters. Let's see what the question's asking. How much time, again we're looking for time, for the truck to reach the bottom? So I don't know my time. Now we can assume that before the truck was falling, its initial speed was 0. A lot of times when you don't know a initial velocity, when it's not given to you, you can make an assumption that it's going to be 0. Let's see. I'm going to make this is actually my displacement. So the distance that I fall is going to be negative 33.5 because we're falling down. And this is the hard part. Well, what's my acceleration? You say it's not listed, but I do know that my acceleration when anything is falling is going to be negative 9.8 meters per second per second. This is a free fall problem. And when something is in free fall, you automatically should write that your acceleration is negative 9.8. Now, since I'm looking for time, I need an equation with time in it. I can't use this equation, the one I used in number 1, because I don't know VF. So I need an equation without my final velocity in it that will allow me to solve for t. So I'm going to use this equation. Delta x is my distance that I fall, that's negative 33.5, equals 1/2. My acceleration is going to be negative 9.8 t squared, that's what I'm solving for, plus my initial speed, which is 0 times t. Now, 0 times anything is 0, so I'm just going to cross that off. And now we just do algebra. Negative 33.5 equals half of negative 9.8, that's negative 4.9, t squared. To get the t by itself, I have to first divide by negative 4.9. So we'll get t squared equals negative 33.5 divided by negative 4.9, 6.8, and the t still isn't by itself. I have to take the square root. So t equals the square root of that, 2.6, and our unit for time is seconds. Alright, there's your free fall problem. Let's move on to number 3. Alright, for number 3, we're looking at a problem where you throw something in the air and it comes back down. You know how long it was in the air, and we're going to try to find the height. So the height is a displacement, so we're going to be ultimately solving for delta x in your equation. But I've drawn a picture here to sort of visualize the problem. Here it's leaving your hands with some initial speed. I don't know what that is, but I know that that's going to be the same magnitude as this speed when it comes back down, because everything is symmetric. It slows down by the same rate till it gets to the top, and then it speeds up by the same rate coming back down. Now I do know the velocity right here is going to be 0, because at the very top of the path it has to change direction. So it slows down all the way up until it gets to 0, and then it's going to speed back down. So using the concept of symmetry, if it takes 5.6 seconds to go up and back down, how long does it take to just go up to its maximum height? I would say we can just divide that by 2. So I'm going to say the time to the top is going to equal 5.6 divided by 2. That should be 2.8 seconds. Let's see. Am I right? Yes. Okay. So it takes 2.8 seconds to go to the top. From here, since I know this time now, I'm going to solve for the height. I'm going to say that my final velocity is 0. I don't know my initial velocity, but I do know the same height it travels up is the same height that it travels down. So if I just isolate, if I just look at the second part and make this v equals 0, my initial speed, I can use the same equation that I just used in number 2 to find my height. So let me just show you how this works out. Delta x equals 1/2 a t squared plus VIT. I'm going to look at just the second part and try to find this delta x, try to find this height. Let's see, 1/2. Now my acceleration is always negative 9.8. This is another free fall problem. Now we know the time to the top is 2.8 seconds, so obviously the time to the bottom is also 2.8 seconds. Plus my time at the top, or my initial speed for this part that I'm looking at, is going to be 0 times the time, 2.8. So 0 times 2.8 is 0. That part completely cancels. and we just need to find this distance. Now this is going to be the distance that it fell, which will then allow us to answer the height. So I'm going to type this in my calculator. 1/2 times negative 9.8 times 2.8 squared, negative 38.4 meters. So the height, if we just want to answer the question, is 38.4 meters high. That means here when we get a delta x equals negative, that negative is just a direction. It means that for the part that I was solving the problem, it went down 38.4 meters. Okay, let's look at number 4. Alright guys, I've already written down for number 4 what we know. We have a car that can go really fast, and we're actually going to be able to reach the speed of sound, 344 meters per second. The question asks us how long it takes to get to the speed of sound, so I went ahead and said my final velocity needs to be 344 meters per second. It gives us an acceleration of 22.4 meters per second, and you have to make the assumption again that our initial velocity is 0. I mean, we have to assume that before we're moving, we're not moving. So it's asking for time. This is nice. I can use this equation. And I expect that while you're solving these, you have a list of equations out, the equations that we went over for acceleration. So that way you can sort of go through and say, okay, what do I have? What do I need? This one works because I have A, I have VF, I have VI. All I need is time. So I'm just going to solve for time here. A is going to be 22.4. VF is what we're trying to get to. That's the 344 minus 0 over t. The same algebra steps as before. To get t by itself, I need to multiply both sides by t. That will cancel out. And then I'm left with 22.4 times t equals 344. Now if I divide both sides by 22.4, I'll be able to solve for time and get t equals 344 divided by 22.4. Oh goodness, 344 divided by, typed the wrong thing in my calculator. I get 15.4. We can just say that's 15 seconds. Now, the next part says, well, how many kilometers? So first of all, I'm going to solve for delta x. Now, know that that's going to give me delta x in meters, but then it's no problem to convert to kilometers. Okay, since I know time, I'm just going to use the delta x equation. That seems the easiest. It's going to be 1/2 a t squared. And I could write the plus VIT, but we know that's going to be 0, because when your initial velocity is 0, that whole part of the equation drops off. So delta x equals 1/2. My acceleration, this is not a free fall problem, my acceleration is 22.4 times t squared. Let's see, my time is 15.4 squared. So I'm going to type that in my calculator. 22.4 times 15.4. Don't forget to square your time. Okay, I get 2,656 meters. Now to convert that to kilometers, we're going to say, well, there are 1,000 meters in 1 kilometer. So essentially, I just need to divide by 1,000 or move my decimal place 3 spaces to the left. So that equals 2.656 kilometers. All right, there's... Yeah. Yep. That's my plan. Alright guys, so we have a baseball player here throwing a ball at 98.6 miles per hour. That 98.6 is really useless for the problem. That's just there to give us some context. But it does go ahead and give us the conversion. 98.6 miles per hour is 44.1 meters per second. It says, how high would that ball go if you were to, instead of throw it out, straight up? So I've drawn a picture here. We know that it's leaving his hand at 44.1 meters per second. And we know at the very top of the path, gravity slows it down. So at the very top of the path, the velocity is 0. While it's going through the air, the acceleration is negative 9.8 meters per second, we need to just find the height. So when you're looking at height or displacement or distance, you're really looking for delta x. So I'm going to use my delta x equation. Actually, no, I'm not. Well, I'm not going to use my delta x equation. I don't have time. It has 1/2 a t squared, and I don't have time. So that's useless. I will use the equation without time. Vf squared equals Vi squared plus 2a delta x. Now, Vf is 0, so 0 squared equals my initial velocity, that's 44.1, plus 2 times negative 9.8 times delta x. This equation is good because my only unknown is delta x, and that's what I'm trying to solve for. So 0 equals 44.1 squared, 1944, 81, plus, this is going to be negative 19.6 times delta x. Now we just need to keep doing the algebra. I need to subtract this from both sides. So I get negative 1944.81 equals negative 19.6 delta x. Now we're going to divide. I'm just doing the algebra at this point to get delta x by itself. So delta x equals 5. Well, I'll see you tomorrow. No, I won't see you tomorrow. Have a good day.
I'll see you in like a week.
Yeah. Yeah, have a good spring break. Divided by 19.6. 99 meters. So, I mean, it'd go about a third of a football field. That's a pretty good height. Pretty impressive. Alright guys, that's all I have for now. I know I didn't do number 6, so if you still really need some help, let me know, and I'll be happy to do that one for you, but at least you have these solutions now. I know this is a 17-minute video, or it's pretty long, but hopefully this helps. Please, you're welcome to email me, contact me during office hours. Just let me know what you need. I will talk to you soon. Bye.